Hi, and welcome to another installment of application development. Today, we're going to be talking about graphical user interfaces, or as I'll call them, GUIs, and some of the ideas behind it in terms of event-driven interfaces, which allows us to have a programmatic interaction with our graphical user interfaces. So, a GUI, I guess, is what we usually interact with in our programming, and something that we might look at trying to create at some point is something like this. And here we can see we have a button, and I can click on this and it'll load some data in from this file here, and I can click on one of these and it populates some information down the bottom. And there's these things called radio buttons. When I click on them, only one can be selected. There's a list through here. So these are all different graphical user interface elements that make our computing so much easier to do. And today we're going to have a look at what we can see through all of those different components and how to use them and why we might want to choose to use those different components. So this is graphical user interface, and we can use Java and NetBeans to create something like this. So there's lots of information out there on the internet about how to create different graphical user interfaces, and there's a couple of links down the bottom here. One for the NetBeans showing you how to use that, and then some documentation from Oracle around how to use Swing, which is the interface we'll use in Java to do that. So stepping back from the Java for a second, graphical user interfaces, right? This is what most people use, whether it's on a desktop machine or whether it is on a mobile device, a tablet. We're all using some sort of graphical user interface. But a lot of the work that we've done so far in this topic has been around using a command line application, and that's where we all started way back in the day, where we type on the keyboard and we get a response and we type something back through there. And I guess these command line applications that we've developed so far, they really lack that rich user experience that we're all used to using. So there's no audio or video. There's no nice buttons that you can click and get feedback and response from. So while we build applications, we really want to be building a graphical user interface. So with a GUI, we're not limited to responding to prompts in a sequence, so in some sort of particular order, and receiving the feedback all in one place, right? So on that command line window. So with a graphical user interface, right, the user sort of drives the interaction, right? I want to, if we jump back over here, I want to interact with this part of it. I want to interact with this here. So there's no sort of sequence. It's up to the user to choose which bit they're going to interact with next. Right? And so it's not this nice logical flow of a command line. It's just it's somewhat almost random what's going to happen next through here. I can click on this button instead, and something happens. And I click over here. So this is what our graphical user interfaces give us, this ability to switch and change what's going to happen. So this process is known as event-driven programming. So something happens and the program responds to that event occurring. Instead of it being what we'd call the normal approach, which is the control flow based programming. So we start at the main, and then something happens, might have an if statement, bit of a choice, maybe you have a loop, go around and round, but it's very control flow based. So those control flow statements, such as an if and a while, that drives the sequence of how the program works. Then it keeps going until we get to the end of the program or exits written or something like that, right? So it stops. Event-driven programming is different in that it's not the control structures that decide what happens, it's the events. And as it says here, it's unable to predict the time and occurrence of the event. So it's not like, okay, here it is, now enter something on the keyboard, now wait until it happens, and I know that was going to occur. Someone could click a button, or click a different button, or click a radio button, or click in a list, or do something else, stop, push, play on touch a certain part of the interface. So what usually happens is we start with the main, as before, but we build the graphical user interface, and then it awaits events. And then someone clicks on a button, we capture that, and we do some processing. So it's event-driven programming. So it's a different way of thinking about our programming idea. So it's no longer for loops and if statements in a sequence. It is events, which we don't know when they're going to happen. So event-driven programming in Java has these concepts of listeners and event objects. So during implementation, we implement these event listeners. So they listen for something that's going to happen. Basically, they register themselves as being, I want to know when something occurs. I want to know when someone clicks on a button there. So there's usually one event listener per widget, a widget being like a button or a list. And you have something, you click on it, and we do something with that. You could have more, so there could be lots of things waiting on something to happen, but most of the time we'll have one listener for one button that occurs. We need to register the listener with that widget object. So when we're programming it, we say, okay, I want to register the listener on this widget object, and then when someone clicks on the button, Java generates an event object and passes that off to the listener, saying that something has happened. So this is known as an observer design pattern through here. So event-driven programming in Java has lots of listeners and it has lots of events that can occur through here. So here's a list, but let's have a look at so this is the event listener API in Java, and hopefully you can see that there's quite a lot, right? Lots of here. So these are all known implementing classes, all known sub-interfaces. There's a lot. So there's a lot of listening and actions that occur in Java through here. So let's have a look. We can zoom in a bit here and have a squiz that we've got a few here. And one you might have seen before is this one called an action listener. Click on action listener here, and action listener is the one that gets used with a button. So if we just jump back out here, so clicking a button in a GUI generates an action event, and so the action event, scroll down through here, is just a class. So this is the action listener, and we can see that it has one method. It's an interface. Let's have a look at that. So it's an interface, so it just defines behavior. And one method is action performed. That's it, right? So I say, I want to be an action listener. I want to listen to a button. I need to implement the action performed. And I implement that action performed, and I get passed an action event. And this action event contains what happened in there. So if we have a scroll down through here, we can see the action event has something called an action command, which we can associate with that button that we push, whether there's any modifiers that were pushed down. So modifiers are things like the control key or the alt key, when it happened, and then some other information that you can pass through to it. So we can use this. Sometimes you don't use the action command or don't use the action event. You just want to know that it occurred through here, that you get notified that it occurs. I guess the thing to take away from this is that there's a lot, right? There's a lot of different ones that can occur in here. So this model, that this event-driven programming idea is used quite a lot in Java and also in other programming languages. So this idea that I want to register, that I want to be notified when something happens, you listen for it, and then when it happens, you get notified and you can process that. So this is this event-driven programming idea.